Okay, so there is a compound which we call it 1-naphthol. It is a phenolic compound. So if you see its structure, there is a one benzene ring in 1-naphthol, and then there is another benzene ring, and out of these two benzene ring, on one benzene ring, OH group is present. That's why I have called it a phenolic compound. So if anyone recall, when there is a phenol, so the electrophilic substitution occurs on what positions in phenol? Yes,
2, 4, 6.
2, 4, 6. So it means these are these three positions which I have highlighted, right?
Yeah. Yes.
So if you see in this 1-naphthol, this one is not available because here there is already another group, so all four bonds are there, and there is already, instead of hydrogen, there is something substituted. So only these two positions are available for the substitution. So the important thing is there that benzene we know is less reactive than phenol. So in this case, no substitution is going to occur on the ring which is simple benzene. The only substitution occurs at a ring which have a OH group, which is phenol, and only at the rest of the two positions where there is no substitution. Is this understandable to all of you?
Yes, sir.
Yes, Kubra and Yusuf? So I can write that the substitution occurs at only 2 and 4 positions of the phenolic ring. So if you will write an equation, for example, with bromine, in phenol, we are getting a tribromophenol, right? But in this case, when this is reacted with bromine, then only substitution occurs at two positions, which are these two only. Is this clear?
Yes.
In the same way, when I react this 1-naphthol with concentrated nitric acid, so the nitration also occur at only two positions. One is this NO2 and the other one is this, these two. Yes. If any one of you have any confusion, please ask. Is this understandable to all of you?
Yes, sir.
Okay. Now, there are the reasons which examiner ask, and it is about acidic strength of phenol, water, and ethanol. So, we know that the acidic strength depends upon the concentration of hydrogen, and we further know greater concentration of hydrogen ions more stronger the acid is. Is this understandable? Yes, if there is a greater concentration of hydrogen ions, then
Yes.
it
Yes,
will
sir.
be a stronger acid. Okay. So if you recall the ionic equilibria, it also gives us some relations. One is that the acid dissociation constant Ka is directly proportional to the concentration of hydrogen ions, which means that if Ka value is greater, then it is a stronger acid, and if Ka value is smaller, then it is a weaker acid, right? That from further aspects of ionic equilibria, we got another relation that is a pKa and the hydrogen ion concentration, and it states that the hydrogen ion concentration is inversely proportional to the pKa. So it means
So,
if
sir, more hydrogen atoms mean higher Ka value?
yeah, if there is a more hydrogen ions in the solution, then its Ka value will be higher.
Okay.
And if the pK value is smaller, then it means there is a more hydrogen ions in the solution, and the solution is basically a stronger acid.
So it's the opposite.
Yeah. And if pKa value is greater, then there are lesser hydrogen ions in the solution and it's a weaker acid. Is this clear to all of you?
Yes, sir.
Yes, Yusuf and Kubra?
जी sir.
Okay, you guys just give me a minute, please. Yes. Okay, he's joining online. Okay. Now, when acid dissociates, what it produces? Yes. When we dissociate the acid, what it produces? Acid produces a hydrogen ion, right? And the negative ion, which is basically the conjugate base, isn't it?
Yes, sir.
Okay. So here we have a three acids. We are going to discuss about three compounds. One is phenol, the other one is water, and the third one is ethanol. So the molecular formula is phenol is C6H5OH. On dissociation, it will form C6H5O negative, which is the conjugate base, and a hydrogen ion. When we talk about water, H2O, on dissociation, it dissociates to give hydrogen ions and hydroxide ions. And here we have a ethanol, which on dissociation also produces a hydrogen ion and ethoxide ion C2H5O negative, which is its conjugate base. So the conjugate base of phenol is phenoxide ion. Here it is hydroxide ion, and here it is ethoxide ion. So if we look at the pK values, the pK value of phenol is 10, water is 14, and ethanol is 16. So what does the pK value telling us about their relative strength? Which one is more stronger acid among these three?
Phenol.
Phenol, as we have seen that smaller pK means stronger acid. So among these, the smaller value is of phenol. So phenol is a stronger acid. So I can comment that phenol is stronger acid than water and ethanol. And I can further comment that ethanol is weaker acid than water and phenol. If I give a statement in context of water, I can write that water is stronger acid than ethanol, but weaker acid than phenol. Is this understandable to all of you?
Yes, sir.
Okay. Now we have to understand the reasoning behind this. What makes phenol stronger acid and what makes ethanol the weakest acid? So, but it clearly means that if I have a solution of phenol, water, and ethanol, phenol have a higher concentration of hydrogen ions than water and ethanol, and water have a higher concentration of hydrogen ions than ethanol. That's why phenol is the strongest. Water is intermediate strength acid, and ethanol is the weakest acid. Is this point is clear to all of you?
Yes, sir, it's clear.
Okay, yes, Kubra, Yusuf, and Hassan.
जी sir.
Okay, now let's have a look at reason. For example, I'm right now going explain you their acidic strength in context of these molecules. So the structure of phenol is like this. The structure of water is like this. And ethanol is like this. So as their acidic strength, I can place these greater than sign like this and say that it is the strongest acid and this one is weakest acid. It's phenol, water, and one ethanol. So actually, the OH bond is a polar bond. due to the electronegativity difference between oxygen and hydrogen. So when the hydrogen ions produces, those hydrogen ions are produces from, as this hydrogen is released, which is bonded to oxygen. Is this point is clear to all of you?
Sir, can you repeat it?
I am saying that this hydrogen, which is bonded to oxygen, the hydrogen of an OH group, is the one which is actually released in the solution as a hydrogen ion. And
Yeah.
it happens due to the difference in the electronegativity of oxygen and hydrogen.
Oh, okay, okay.
Okay, so the thing is that we have studied in AS that if you recall the nature of the alkyl group, so basically alkyl group is electron donating in nature. Oxygen have an electron withdrawing nature, so it tries to withdraw the electron, and as alkyl group is electron donating in nature, so it induces its electron towards this oxygen, and as a result of this OH bond gets stronger, and if this OH bond gets stronger, and basically it gets stronger than the OH bond in water and phenol, that's why ethanol is less likely to form hydrogen ions as compared to water and phenol. So there will be a lesser concentration of hydrogen ions in the ethanol solution, and that's make it weakest acid. Is this clear?
Yes, sir.
Okay. In the previous class, we have discussed, we seen that oxygen is overlapping its lone pair. So basically, oxygen is inducing its electron, it is providing its electron to the phenol, and hence it tries to neutralize its charge. It tries to take the electron from the hydrogen that makes this bond weaker. So as a result of electron withdrawing nature of phenol or of benzene ring, the OH bond in phenol gets weaker than the OH bond in water and ethanol. Therefore, phenol have more likely chances to release its hydrogen bond in the solution, and as a result there will be higher concentration of hydrogen ions in the phenol solution as compared to water and ethanol. That makes phenol a stronger acid than water and ethanol. Is this clear?
Yes.
Okay. Then when we discuss it in context of water, in water there is a hydrogens bonded to oxygen, and as there are hydrogen bonded to oxygen, so these hydrogens are neither electron donating nor electron withdrawing. So that's why this OH bond gets stronger than the OH bond in the phenol. So that's why it's less likely to break to form hydrogen ions as compared to phenol, but it is weaker than the OH bond in ethanol, and that's why it becomes it produces more hydrogen ions than ethanol, and that's make water less stronger acid than phenol, but more stronger acid than ethanol. Yes, is this clear to all of you?
Yes, sir. Clear.
Okay. So that's what I have explained you. Just give me a minute. Okay. So this is how you explain it. This paragraph is in context of phenol. This is in context of ethanol, and this, oh sorry, water, and this is in context of ethanol. So just note these down quickly, and while noting down, if you find anything ambiguous or unclear, please ask. Okay.
sir. Yes.
So this is, we have seen their acidic strength and their comparison in context of these molecules. But you have to understand, if you have to explain their acidic strength in context of the conjugate bases they form. So let's talk about this. Acidic strength of phenol, water, and ethanol in context of conjugate bases. So, as we know that when acid dissociates, it dissociates to produce a hydrogen ion and conjugate base. So basically, this is how an acid reacts. When acid reacts, it forms a conjugate base and the hydrogen ion. Is this point is understandable to all of you?
Yes.
Okay. Now, how conjugate base will react? When it reacts, what it will do? So when conjugate base undergo a reaction, what it will do? That conjugate base accepts hydrogen ion to form acid again. So that is how a conjugate base reacts. So now think, okay, first how it accepts the hydrogen ion, because hydrogen ion have no lone pair. So basically conjugate base accept it by providing the lone pair or by sharing the lone pair of electrons. Okay, now think of the two conjugate bases. One have a very high tendency to gain hydrogen ion to accept a hydrogen ion. It accepts the hydrogen ion very readily and turns into acid, undissociated acid molecule. And the other one accepts the hydrogen ion with a difficulty, takes more time, do not accept hydrogen ion readily to form acid again. So which out of these two, which conjugate base will be of a stronger acid? The one which reacts readily or the one which reacts less readily? Yes. Which?
Sir, can you repeat the question?
Yeah. I asked that which conjugate base, the one which accepts the hydrogen ion readily or the one which accepts the hydrogen ion less readily, belongs to a stronger acid?
One that accepts readily.
If it accepts readily, then what will happen to the concentration of hydrogen ions in the solution?
It will decrease.
It will decrease. So will it going to be a stronger acid or a weaker acid?
Weaker.
Weaker. So the one which accepts the hydrogen ion less readily, that conjugate base belongs to the stronger acid. Is this clear? Because
Yes, sir.
if it is accepting the hydrogen ion less readily, then it means that there will be more hydrogen ion concentration in the solution, right? Yes, Kubra.
Yes, sir. Yes.
Okay. Yes, Kubra, Yusuf, and Hassan, is this clear to all of you?
जी sir.
Okay. So, just give me a minute, please. One minute. So, the conjugate base of phenol is phenoxidine, right? And this phenoxide ion, the oxygen have a 3 lone pairs of electron. The conjugate base of water is hydroxide ion, where this oxygen also have a 3 lone pairs. And the conjugate base of ethanol is ethoxide ion, right?
Yes.
So, what benzene do with the oxygen? Can anyone recall? The benzene ring withdraws the electron from the oxygen, and as a result, oxygen overlaps its one orbital having a lone pair of electron with the pi system of benzene ring, right?
Yeah.
So it means in case of phenoxide ion, the lone pair are less available because they are delocalized in the pi ring.
Yes, sir.
So it means that phenoxide ion is less likely to accept the hydrogen ion because of the decreased availability of lone pair. Is this
Yes.
understandable to all of you?
Yes, sir. Clear.
So it makes phenol. So there will be the hydrogen ion will stay in the solution. There will be more hydrogen ions in the solution. So that makes phenol a stronger acid as compared to water and the ethanol. Is this point is understandable to all of you?
Yeah.
Okay. In ethoxide ion, so here what will happening? It is the electron is delocalizing in the pi system. The ethyl group is electron donating in nature, so it donates the electron to the oxygen. As a result, the negative charge density or the availability of lone pair is increased or enhanced in the oxygen of the ethoxide ion, right?
Yes.
So if this happens, then there is more likely to accept the hydrogen ions. And as if it's more likely to accept the hydrogen ion, so it will readily accept hydrogen ion and turn into undissociated molecule, which results in decrease in the concentration of hydrogen ions in the solution, which makes ethanol weaker acid than phenol and water.
Yes, sir.
And here the negative charge density of the availability of lone pair is intermediate, it is higher than this one, because here it is decreasing in phenoxide ion. So it will accept the hydrogen ion more likely as compared to phenoxide ion, making it weaker acid than phenol, and to accept the hydrogen ion is less likely as compared to ethoxide ion, because here the negative charge density is increased due to the electron donating effect of ethyl, and hence water becomes a stronger acid than ethanol. So if you have to explain these in context of the conjugate basis, you will write these three. One is for phenoxide ion, one is in context of ethoxide ion, and one is in context of hydroxide ion. Okay, so if you want to take the screenshot, just take it and then note it down after. Okay, if you guys have any query or any question, please ask.
Sir, how will we know that the lone pair is more readily available
It is because see that
on
this,
oxygen?
yeah, this alkyl group, what it is doing, it is donating its electron to the oxygen. So there are already 3 pairs and it is having more electrons from this. So these pairs are more readily available to be donated, because it is
Yeah.
getting the electrons from this group. Over here, it is overlapping one of the orbital to the pi system. As a result, the availability of the lone pair decreases.
Sir, it's getting the electrons from the delocalized on benzene, right?
The benzene ring actually getting the electron from the oxygen. As a result, one of the lone pair of the oxygen is also gets involved in the delocalization.
Okay, so on oxygen there will be less.
Yeah, in phenoxide, the lone pairs availability will be less on oxygen. And in ethoxide ion, the lone pairs availability will be more. And here it's intermediate in hydroxide.
Okay.
And that's what it is
Okay, sir.
explained over here. Yes, if
Okay.
any one of you
Got
have
it.
any other question, please ask. Okay, is this clear? Yes, Kubra?
जी sir.
Yes, Hassan and Yusuf? Okay, just take the screenshot so you guys can note it down in your notebooks after. Okay?
Okay.
So our next class will be on Friday from 6 to 7. Okay?
Yes, sir.
Okay, is everybody done with the screenshot?
Yes.
जी sir.
Okay, then take care, everyone. Have a good night.
Allah Hafiz.
Allah Hafiz.
Allah Hafiz.